We've been talking previously about right triangles and solving right triangles and solving problems that involve right triangles. But now we're going to talk about oblique triangles, and oblique triangles are triangles that don't have a right angle. Um, they may have three acute angles, all less than 90 degrees, or they might have one obtuse angle, that is an angle between 90 and 180 degrees, and then two acute angles. So we can have a variety of different triangles here. Well, let's remember, okay, the way we deal with a triangle, the way we label sides traditionally. Okay, that doesn't mean that this is etched in stone, but we normally label the angles by capital letters A, B, and C. That C up here is indicating an angle, and so it's a big C, a capital C. And then we label the sides with lowercase letters, and we label the sides lowercase letters associated with the opposite. If angle A is here, then the side opposite it we call side A, lowercase a. Angle B, the side opposite lowercase b. And before C was a right angle, but here it is not. Okay, this is an oblique triangle. So we have an angle C, and the side opposite it is C. And of course, these are all measures. When I talk about the angle A, I'm talking about the measure of it. When I talk about side A, I'm talking about the measure of it, how long it is. Now, to solve an oblique triangle requires the measure of at least one side. We have to know one side and two other parts of the triangle, either two more sides, two more angles, or two angles, or one angle and one more side. We've got to have a side and two more pieces of information. Now this gives four cases. Okay, this gives four different cases. One of the cases where we have angle, angle, side, or angle, side, angle. So we had to have one side. Here's one side and two angles. Here's one side and two angles. Now, we're probably not going to remember this angle, angle, side, angle. But if we go up here, what is meant by angle, angle, side, we would say pick an angle, as we're talking about this, angle, angle, side. Angle, side, angle, well, that would be angle, side, angle. And I could start at any particular place, but I'm just showing you what that means. We could have two sides in an angle opposite one of them. Okay, so now remember we have to have at least one side. Well, here we have one side and then two more pieces of information. Side, side, angle. So that would be like, I'm going to choose to go this well. Let's say side, side, angle. See how that, or if I say here, side, 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 angle. Or here, side, side, angle. Now, notice in each of these cases, as it was mentioned here, if I say side, side, angle, notice I've got a side and an angle opposite it. Or if I say here, side, side, angle, I've got an angle and the side opposite of it. Or side, side, angle, I've got an angle and a side opposite of it. And in this first case, angle, angle, side, angle, angle, side, I have an angle and a side opposite of it. Angle, side, angle is a little different. Angle, side, angle doesn't give me that information, okay? Angle, side, angle, they're all from, they're all different letters, aren't they? But here is one thing I'll point out later. Angle, side, angle, if I know two angles, it's easy to calculate the third. And then angle, side, angle, if I calculate the third, I'd have an angle and a side opposite at that. And that's kind of an important observation for what we're going to do. Okay, so another possibility is given an angle and then, given a side, we have to have one side and two more sides. So we would have three sides situation there, knowing three sides, and we'd have to find the other information. Or we could be given two sides and their included angle. Okay, so two sides and their included angle, that would mean what that said was side, angle, side. Two sides and the angle in between them, side, angle, side. Two sides and the angle in between them. And notice again, those are all from different, all different letters. Side, angle, side. Okay, side, angle, side. Well, there again, they're all different letters. And that's kind of, again, something that's pretty important overall. Now, we actually break these into two, well, let me go to the next page and we'll discuss further. Here's the next page. The law of sines. And the law of sines is one of the two laws we use to deal with solving oblique triangles. The law of sines and law of cosines. Now, the law of sines handles cases 1 and 2. That is, where we have two angles and a side, or two sides and an angle, but specifically, we'll discuss more in a moment. So it handles angle, angle, side, and angle, side, angle, and also side, side, angle. Again, we're not going to remember that. I'll tell you a way to remember that later on. Cases 3 and 4, that's if we know three sides or two sides and the included angle. Okay, that requires the law of cosines, but that's not what we're talking about now. Here's what the law of sines says, is if ABC is a triangle with sides lowercase a, lowercase b, and lowercase c, then these three ratios are equal to each other. Okay, that is side A divided by sine of angle A is the same as side B divided by angle of sine of B, or side C divided by the sine of angle C. Now, those three ratios are equal. When we go to work on something, we only use two of the ratios. We could say, like, put these two together, see? We could look at those two and say, okay, we have an equation. Ignore what we have over here. We have an equation that involves four pieces. Or we could look at these two, the equal sign between these two. We have an equation that involves four different pieces. And it's important for us to recognize if we have an equation that involves four pieces, we need to know three of them to find the fourth. We need to know three of them to find the fourth. Okay. Well, I guess there's not really a big significance here, except that this can deal with a situation where all of the angles are acute, or one of the angles is obtuse and the other two are acute. So, but we don't have any right angles, okay, in this case. Actually, this works for right angle situations as well. It does work for right angle situations as well, but we normally don't use it there. Now, the law of sines can also be written in this reciprocal notation. We usually use the notation up here if we're trying to find a side. We usually use the notation down here if we're trying to find an angle. It just makes it takes fewer steps, if you will. But these two are equivalent in terms of being able to use them in the situation we're concerned about. Whoops. Pardon me here. Well, let's look at a problem using the law of sines. And so here, notice what we're given. Okay, notice what we're given. I said that this is an angle side problem above in my title, and angle side. Okay, so here we're talking about an angle C, an angle B, and a side B. Angle C, angle B, and a side B. Now, I've drawn a pretty nice diagram here, and don't worry that we probably won't deal with diagrams like this a whole lot, but I mean, be able to needing to draw them so accurately. But in this case, I have drawn a pretty accurate diagram, and since C is an obtuse angle, it's more than 90 degrees, then the other two angles are going to have to be less than 90 degrees, and in some to less than 90 degrees, in fact. And here's the angle B, 28 point, it's actually, yeah, 28.7 degrees, yes. And then side B. Now notice in this scenario, I know an angle and a side that's opposite at that angle, and I know one more angle, okay? And again, that's an important observation. So, since we know two angles, and what are we supposed to do? Well, we're supposed to find the remaining angle and side. So we have another angle we need to find, that's angle A. We need to find side A, and we need to find side C. And then we will have solved the triangle, if you will. Find all of the components of the triangle. Well, since we know two angles already, then the third angle is very simple because the sum of the angles has to be 180 degrees. So if we take 180 degrees and we subtract away the measure of the two angles we know, then we will have the angle, the third angle, and in this case that's angle A. So I've just shown that that's what I've done. Okay, so now we're interested in calculating or determining the other two sides. And so I'm going to use the law of sines here, okay? And what I'm deciding to do, in this case is use the relationship A over sine of A is equal to C over sine of C. Now that's the form that I'm using. I've decided for some reason I could have chosen. I've decided I'm going to calculate side A. Okay. Excuse me. I've got this all screwed up, don't I? My bad. What have I done here? Okay, back to our problem. I had a pause there. Maybe you couldn't tell, but certainly you can see a difference now. Let's stop and think. What we need is angle A, and side C. And for some reason, I've just chosen to find side A at this point. I could find side C, but I've chosen to find side A. So I'm looking for side A, so I've got to involve this part of the law of sines, A over sine of angle A. Now, to use the law of sines, I need to know two other pieces. That is, I'm looking for side A. I know angle A, and I've got to use a formula where I know the other two pieces, because I've got to, of the four pieces, I've got to know three to get the one. So it wouldn't do me good to say is equal to C over sine of angle C, because I don't know C and I don't know A. But I know side B and angle B, and so that's the reason I've chosen to use this form. Now, I'm looking for side A, so I take this equation and just multiply both sides by sine of A. And I could use it in the form here, or I could use this totally fraction form. But that's what I've done. So using this information, side A is B over sine B, which comes from here, times the sine of angle A. And we know B is 27.4. And we know angle B is 28.7 degrees. And we know angle A is 49 degrees from our above calculation. So we just go about and do that computation. And, here I guess we could show that computation. It's not that big a deal. Probably the way I would do it is I would use the form that I've got here, just so that I have it all together. So what I could say is, I could say, let's turn my calculator on. Let's clear it. I'm already in degree mode. I know that. So I'll say it's 27.4 divided, let's say times. Well, I guess it doesn't matter here. Let me back up. Let me back up. If I'm going to put it all in the numerator, I'm going to say, okay, the numerator is 27.4 times the sine of 49 degrees, close sine, close numerator, divided by the sine of 28.7 degrees. 28.7, close sine. Enter. And I get 43.06 and so on. And you see I've rounded it to 43.1 feet. And I took my clue that the one side I know is to the accuracy of 1/10 of a foot. And so that's the reason I chose to round to 1/10 of a foot, to the 1/10 position. Okay. So now what do we know? We know angle A and we know side A, and the only thing left is to figure out what side C is. And to figure out what side C is, I just use the other part of this formula. I could say that C over sine of C is equal to B over sine of B. Okay, I could use that. And if I use that form, then I would have, in fact, let's show that. So again, my point was, or is, that I'm looking for side C. And I know everything about the B's. I know side B and I know angle B. And I happen to know angle C too, don't I? Okay. We know angle C. Whoops. I don't know what I was recording. We know angle C. And so if I want to find side C, I would use this relationship. And then I could take this actually and solve for side C by multiplying both sides by the sine of angle C. And so then I would just fill in the pieces. So that's what I've done here. Okay, I know B is 27, the side B is 27.4. I know angle A is 28.7, and I know angle C is 102.3 degrees from above. Okay, and so as I go through that calculation, what I did a moment ago, I would get 55.7 feet. Remember, things are measured in feet here. And I rounded to the 10th position again because my original information, the sides were in tenths of feet. Okay. Notice this too. This is something that I'll repeat later on. The longest side is 55.7 feet, and that's side C. And that's going to be the case. The longest side will be opposite the largest angle. Now, what are our two angles? Well, one's 28.7 degrees. That's angle B. Well, side B is 27.4. The other two sides are bigger. Yes, the smallest side will be opposite the smallest angle. That only makes sense, doesn't it? Okay. Well, let's move to the next page here. Let me make a couple of points, and this is really what I just said. Don't forget to check the feasibility of your answer. Using your sketch, remember that the longest side of a triangle lies opposite the largest angle, and the shortest side lies opposite the smallest side. Okay, so here's the largest angle. Here's its side that's larger than the other two. Here's the smallest angle. This is its side. It's smaller than the other two. Okay, keep that in mind. Now, also keep in mind that when we're using the law of sines, this is what the law of sines says, but we only use one equation at a time. That is, we only use one pair of fractions at a time. And as it says here next to it, to use the law of sines, you must have one angle and the side opposite that angle. In addition, you must have an additional angle or additional side. So let me just stop and think about here. Let's take this first example. If we're going to use the law of sines in this form, we have 4 pieces of information. And if we're going to solve, we're looking for one piece of information, and we can't solve for that one piece of information if we have an extra unknown. So that is the idea. We have to have three of the pieces of information. We're looking for one of the pieces. Well, if we're looking for this piece, then we've got to know these two pieces, B and angle B, and that's an angle and the side opposite of it. Or if we're looking for angle A as an example, then we'd have to know the other three pieces. That would be these two, these three, and that means we'd have to know side B and angle B, that is an angle and the side opposite. Okay. If, on the other hand, if we were looking for B, we'd have to know these other three pieces, and that would include angle A, side A and angle A. That's an angle and the side opposite. So to use the law of sines, you have to have an angle and the side that is opposite that angle. That's what you need to remember. To use the law of sines, you must have one angle and the side opposite that angle, and then one more piece of information. Well, let's move along to the next problem. Well, I've given away too much information again, so let me hide some of this. Okay, in this problem, you see that we have a pole tilts toward the sun at an angle, 8-degree angle from the vertical, and it casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? Well, it takes a bit to interpret what we're being asked for. After we interpret that, or as we're trying to interpret, we draw a sketch. So I've drawn a sketch. So this green is the pole, and it's tilting toward the sun. And the angle, let's say, at an 8-degree angle from the vertical. So here's vertical, and so the angle between this vertical dashed line and that pole is the 8 degrees. It's that tiny angle in here. Okay. The angle of elevation from the tip of the shadow to the top of the pole. Okay, so this pole is going to cast a shadow down here. Okay, cast a shadow. The shadow is 22 feet long, and the angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. So this angle is 43 degrees, and this is the length of the shadow, 22. And so now the next thing I've done is just start labeling some sides and angles. So I called this angle A, and that's the 43 degrees, and I called this angle B, which is greater than 90 degrees, isn't it? In fact, it's 90 degrees plus 8 more, so it's 98 degrees. And then I called the angle up here angle C, that's the angle up here. And then appropriately, the side that is opposite angle A is side A, the side that is opposite angle B is side B, and the side that is opposite angle C is side C. We know side C, we know angle A, and we are not given angle B, but we can calculate it real quickly, can't we? Now, what is it we're trying to do? We're trying to find out how tall the pole is. And so A is actually the length of that pole, isn't it? A is the length of that pole. So that's really what we're trying to do, is to calculate side A. Whoops. Now, whoops. Okay. I've done two things at once here. We know A is 43 degrees, and we know angle B is the 90 plus the 8 degrees, that's 98 degrees. And we know side C is 22 feet. Now, I'm trying to here. Let me tell you what I'm trying to do here. Is I need some relationship. I'm looking for A, and so that tells me that I'm going to use A over sine of angle A as part of my law of sines. But to complete the law of sines, I need an angle and the side opposite of it. Well, I already know the side C, and so if I could come up with the angle C, that'd be good. And because I know two angles, I can easily find the third angle, C, and then I'll be set. So angle C is 180 degrees, the sum of all of the angles in a triangle, minus the two angles that I know. And that calculates then that C is 39 degrees. So now I know angle A, I'm looking for side A, but I know angle C and side C, and so I'm set to use the law of sines. And this is the form I'm using, okay? I'm looking for A, I know angle A, I know side C, and now I know angle C, so I'm set. Okay, well, let's get to work then. I'm going to take that information, that form, and I'm going to multiply both sides by sine of A. So to calculate side A, I'll have C over sine angle C times sine of angle A. And I'm just now plugging in the values. And so side C is 22 feet, angle C is 39 degrees, angle A is 43 degrees. When I put this into my calculator, I get 23.8 feet. 23.8, and I know it's measured in feet. Okay. And I just decided to round to the 10th position. I wasn't given any more information. Maybe I should round that to 24, but I decided to round to tenths of feet. Well, let's see what we have in store next. Okay, in our next problem, you see the course for a boat race starts at point A and proceeds in the direction south 52 degrees west to point B. Then in the direction south 40 degrees east to point C, and finally back to point A. Point C lies 8 kilometers directly south of point A. Approximate the total distance of the race course. Oh, again, we have to draw a diagram, which is a little bit involved here, okay? So I'm thinking of north, south, west, east, okay? So it said it starts at point A and proceeds to point B in the direction of south 52 degrees west. So here's my north-south, here's my east-west set at point A, and my direction is south, so measured off the south axis, 52 degrees to the west. So it's this angle that's 52 degrees. Now, it travels to point B, okay, along that direction. Now, when we get to point B, the course changes directions. Now, I've drawn this vertical here to think of the north-south axis, okay? And, of course, the west-east axis would be right through B in this direction, okay? So when we get to point B, then we turn in the direction south 40 degrees east. So that means off of the south axis that's here, we're 40 degrees, we measure 40 degrees to the east. And so it's this angle in here that I've labeled as my 40-degree angle. Okay, and it also says point C lies 8 kilometers directly south of point A. So we know that this distance is 8, and O, that happens to be, I'm going to call, I'm going to use also the idea of point A as angle A, point B as angle B, point C also is going to refer to angle C. So if this is angle B, then this is side B. And of course, if this is angle A, this is side A. And we'll also need side B. So what we need to see, so we need to know this side, which we'll think of as lowercase c. We'll need to know this side, which we'll think of as lowercase a. And we already know lowercase b. So we need to know these two sides so we can add all three sides together. Okay. So that's the plan. Now, I need to start gathering information, and I only know, let's stop and think about this. If I'm thinking I may want to use the law of sines. I'm not sure yet, but that's what I'm thinking. I certainly do not have a right triangle. It kind of looks like it, but it's not. Um, so don't let images fool you. Now, the only thing I know about this triangle is I know one angle and one side, and I've got to have more information. So I don't have a whole lot of hope of calculating another side immediately, but I do have hope of calculating another angle pretty quickly. And so this is what I've said here. Angle BCA is 40 degrees. That is, angle C is 40 degrees is what I said. Now, why do I know that? Well, if we remember some old geometry, let's create a right triangle here. Remember, this is the north-south axis, okay? And so if I think about making a horizontal there, then here's what I know. Here's what I know. And also, this is north-south. Remember, it said that point C lies directly south of A. So these two lines are vertical and parallel. Now, if I look in here, I've created a little right triangle. And this angle is 90 degrees, this angle is 40 degrees, and so this angle has to be 50 because the other two angles have to add to 50. So this angle has to be 50. But if this angle is 50 and this angle is a right angle right here, see, then I know this angle is 40. And that's how I made that decision that this angle C, remember the angle C, whoops, wrong thing. Remember, angle C is this angle. I just put that extra piece in there so we can think about it. But angle C is actually this angle, and we decided this angle inside is 50 degrees, so that's why this had to be 40. Well, I keep goofing that up, don't I? Okay, in fact, if you will, these are transverse angles, aren't they? Or they're interior angles, if you will, of a transverse to two parallel lines. And so from geometry, we should have known that this was 40 degrees anyway. But I've explained it here. So now we know, see, we know angle A and we know angle C, and so we ought to be able to calculate angle B. B is 180 degrees minus our angle A, which is 50 degrees, minus our angle C, which is 40 degrees. So angle B is 88 degrees. It's not a 90-degree angle, although it's close, isn't it? Well, now what good does that do us? Well, now we know an angle B and the side opposite. We know angle B is 88 degrees and the side opposite is 8. And so the law of sines is appropriate. Okay. Now, the law of sines is appropriate. We know all three angles. We know one side. And so we can use this one side and the left part to calculate side A, and we can use the right part to calculate side C. And so that's what we're going to do. So A is sine of 52 degrees times 8 over the sine of 88 degrees. That's how I calculate. A is this fraction times sine of 52 degrees. And the B value is actually 8. And so I used my calculator and I got approximately 6.3. And now I know that C, see, I don't know C, but I know B. So I know C is the sine of 40 degrees times this fraction. And of course, this fraction is 8 over sine of 88 degrees. And that's what I've shown right here. And I use my calculator to calculate 5.1. So now I know all three sides. The total length of the course then is the sum of all three sides of that triangle. And of course, one of the sides was the 8, that was side B. And one of the sides was 6.3, that was side A, that's the side over here. And no, excuse me, that's the side right here. And the third side, side C, which is side up here, is 5.1. So when I add those together, I get 19.4 kilometers. So the total length of the course is approximately 19.4 kilometers. Well, that's the end of this part of the discussion of law of sines. Now, um, let me kind of tell you what we'll do next. There's a secondary part, a separate video that discusses something called the ambiguous case of the law of sines. And if you notice here, in every case, we've only used the law of sines to calculate the length of a side. We've sometimes had to calculate an angle, but we didn't use the law of sines to calculate an angle. And then the next problems, we're going to have to use the law of sines to calculate an angle. And that causes some unexpected results. Well, signing off from this discussion.